Let's find some integrals. Here I have an indefinite integral and a definite integral, and I just want to evaluate them. So starting off here with number 1, x squared over x squared plus 1. I always think it's a good idea to have students pause a video or in a lesson take some time to see what they might think to do on this one. So I invite you to do that now. Pause the video and just attempt things that you know to try to evaluate this definite integral. I have a feeling some of you tried substitutions, and I have a feeling that you didn't have much success there. So we're going to have to try something else. And on the inside here, what I see is polynomial division. So I'm going to rewrite this as a quotient plus the remainder over what I was dividing by. I'm going to do the division and rewrite the integrand. So I asked myself, how many times does x squared plus 1 go into x squared plus 0, x plus 0 with those placeholders? And it turns out it goes in there exactly 1 time, giving me an x squared and a plus 1. I changed all of my signs to actually subtract when I'm thinking about the long division of two polynomials. Those cancel, I have no x's, and it gives me a remainder of minus 1, telling me that x squared over x squared plus 1 is equal to 1 minus 1 over x squared plus 1, letting me rewrite my integrand. And these are two functions that we do have antiderivative formulas for. The antiderivative of 1 is, of course, x, and the antiderivative of 1 over x squared plus 1 is the inverse tangent function, plus c, of course. All right, so we had to do some long division of polynomials to evaluate that one. Context clue to help me understand when I'm going to do that is when my rational function on the inside here is not in lowest terms, when the degree of the numerator and denominator are either the same or the degree of the top is actually more than the degree of the bottom. Looking at this one, I see the square root of 1 minus cosine theta. And I don't know, I need to think about where I might have seen some trig identities to help me with this one. And so I have a pair of identities here that I like to think about. They're the power reducing formulas. If you take square roots of both sides, they actually become what we call half angle formulas. And so if I look at this bottom one and imagine taking the square root of both sides, I'd have sine of t is equal to the square root of 1 minus cosine of 2t all over 2. All right, I realize that mine doesn't have a 2t in it, it has a theta, so I could just say, well, let theta be that 2t. And then this formula would become that 1 minus cosine theta. Well, this is just t, and doing that substitution, t would have to be theta over 2. What we've really done here is turn this into that half angle formula without much effort, and to really make it look like this one, I have to think about multiplying both sides by the square root of 2. So that integrand, the square root of 1 minus cosine theta, is equal to the square root of 2 times sine of theta over 2. d theta. And if I happen to just have the half angle formula memorized, I could just use it instead. But I don't know, I thought I'd start with that identity just for fun. All right, so now I have to evaluate this integral, and I can certainly pull the root 2 out front, and that would leave me with a sine of theta over 2 to deal with. And we can just find an antiderivative at this point. And so let's just go on and do that. The antiderivative of sine is minus cosine of that theta over 2. I didn't need to have a 2 out front. Thinking about that rule, I could also do a substitution, let u equal theta over 2, and I see where that 2 pops out from. Oh, let's see, 2 root 2, then that minus cosine of theta over 2 evaluated from 0 to pi halves. All right, getting real close to the bottom of the board here, I have 2 root 2 times, and when I evaluate this, I plug in the pi halves, it actually becomes a pi fourth, so I get minus root 2 over 2. and then I plug in that 0, and I would get a minus minus 1. So when I distribute, let's see what I would get. Let's see. Well, I'll get that 2 root 2 to be positive when it multiplies to the 1, so I'm going to write that out front. And when I multiply this in here, well, I'm just going to get a minus 2. And there's my nice, happy final answer.